Midwest Engineered Systems basically does process-intensive and highly engineered automation systems. Everyone that comes here is pretty much looking for something that doesn't exist, and we're the guys that they come to get it done. We've actually came up with a way to print with metal using wire. Really what that does is allows you to print larger parts, and it allows you to print them faster.
We developed an additive manufacturing system using the hot wire process in order to preheat the wire before it actually gets into the molten pool. That means we can put down metal up to 20 pounds an hour without a blink of an eye in order to build large, huge parts.
Additive manufacturing provides a capability that isn't known commonly for manufacturing methods. Rather than combining materials in a welding platform, using molten metal in a casting operation, or taking a block of metal, machining it, now we can take a simple material like a powder or metal and add that material up in a welded platform so it ends up creating a component from scratch. The unique aspect of our additive manufacturing system is not only is it heavy deposition using high power lasers, it also uses a heated wire so that we can put a lot more material into the component as we're building it, but we also combine that with large positioners and a large working environment.
Yeah, there really is no limit on size. I can take a KUKA robot and put a large track on the floor as long as the customer is good with the room that it goes into. There's really no limit on how big of a part you can make. The bigger problems are the physics of printing the parts. You know, is the part going to warp, or if the part does warp, how to contend with the warp.
We need to have way more control over that liquid metal, what we are depositing. All of that is being controlled in a closed loop system. Within a millisecond range, we are reading sensor readings. We are evaluating those sensor readings, and we are applying changes to the robot path, the robot travel speed, the laser power, the welding wire speed.
The system is constantly monitoring and storing that data. We can guarantee that the quality of the material is consistent through the entire build structure because we're monitoring the heat and the deposition of the material constantly through the process. There's cost efficiencies in the overall system because there's less machining time necessary because we're not taking as much of the component out.
It can bring the cost down for making parts. The more expensive the material and the less of that material that you actually have to use or start with is certainly something that a lot of people see.
Our system can be used in the aerospace industry since we are using exotic materials like titanium. We also can use that in the defense industry with duplex stainless steel, or you can use it in the general industry with regular carbon steel in order to build any part what you can think of.
Yeah, it's entirely possible that we could build an entire wing structure within one of our cells. It's huge savings. That, and if you look at the energy consumption of a foundry versus what we're providing in this environment, because it's direct energy deposit, you're going to find that all the energy is necessary to melt the material right where you need it. There's very little waste, and you get the component faster.
You can build your design right on your computer. You download that program to the robot system, and you can produce a part within hours instead of waiting months to get that part into your hands. For our additive manufacturing program, we choose the KUKA robot. One of the biggest reasons was the open architecture of their control system.
When we're looking for a rigid arm and the ability to provide very unique software that integrates well with the robotic system, KUKA is our brand of choice.
Since we are working with several different customers and the size range and the application always is a little different, we can choose from a great product range for that application. So we might end up using a 300 kilogram robot, or we might up using a 90 kilogram or just a 30 kilogram robot, depending on the application for reach as well as the payload for that equipment.
Before you were using this platform to simply join pieces of material together. Now we're going through an additive process that creates components from scratch in a metal format that creates grain structure and characteristics that are unique to this process.
The technology that we're actually coming up with here is pretty astounding, and I see that in the next maybe 5-10 years, this stuff will be mainstream. We see our growth in additive manufacturing right now pretty steady.
Orange Intelligenz.